Hello, stargazer, and welcome back to Earth Sky. I'm Deborah Bird, and maybe you've heard that there are not one, not two, but three comets in our sky now. One of them is pretty tough to see, but two of them you've got a shot at. I'm here with my friend Bob King.
Hi, everybody.
Hey,
Nice to be here,
hey.
Debbie, as always, especially talking about comets, which is really my favorite subject in astronomy.
That's right. And we've got three comets on this slide that we're showing right now. We've got all three of the comets that we're talking about. Comet Lemmon is the big bold one on the left here, or at least it's on the left to us. I don't know if it'll be mirrored or not. The one in the middle is Comet Swan, and the other one is Comet Atlas, the interstellar comet.
Yes, and two of those, Comet Lemmon and Comet Swan, are both visible right now from a reasonably dark sky in a pair of binoculars. Comet Atlas is still too near the sun, but it will soon appear in the morning sky where we'll be able to see it through a telescope.
Yes, and Comet Atlas is the one that's from another star system, so we're going to be talking about that last. But first, we want to show you the two comets that you might be able to see right now.
This is a beauty. This was taken not too many days ago. I photographed it in the morning sky when it was visible both in the morning and in the evening. Right now, the comet is best after dusk. But you can see the beautiful little bright head of the comet and the tail. And both of those were visible in my ordinary 8x40, 8-power binoculars. I could see the head and then kind of a stubby tail.
Yes. And so this is a beautiful comet. And as Bob said, it really helps to have a dark sky. Let's look at the chart, Bob.
Yeah, and about this comet, there's talk about, can you see it without optical aid? And yes, you can from a dark sky. And don't expect much because it just looks like a little fuzzy patch with the eye. You're like, oh, I can just see it. So it's really nicer in binoculars. And of course, if you have a telescope, it's great. Here's the path of the comet over the next couple of weeks. You can see it. We got a really handy star right now. If you look to the northwest, it's important that you have an unobstructed view to the northwest. You've really got a clear zone down there. You look below the handle of the Big Dipper, not too far above the northwestern horizon, you're going to see a bright twinkling star. That's Arcturus. Can't be missed. If you look roughly a fist to the top or above Arcturus and off to the left, over the next few nights, you'll be able to see the comet. So it's super handy star to help get you there. And then you can also use Alphecca, the brightest star in this little horseshoe-shaped constellation called Corona Borealis, the Northern Crown. So the comet moves to the east and south over the coming couple of weeks.
Yes. And this comet, and we'll go back to that chart again in a second, this comet is the one you have the best shot at because it's the brightest one. Did it pass perihelion this week? I think it did, the 21st. Is that right?
It actually passed closest to the Earth, and this is kind of
passed closest to the Earth.
Passed closest to the Earth on October the 21st. And so it's at maximum brightness, which for those that follow magnitudes, which we use to determine brightness, it's about magnitude 4. So that's definitely within the naked eye, unaided eye optical range, where you can go out and see it. And it does, the reason why it's the best of the three comets, I guess you could call it, is because it looks most like a classic comet where you see the bright head and a little short stubby tail sticking out of it. Again, with a pair of binoculars. Best time for viewing is to go out starting 90 minutes after sunset. So an hour and a half after sunset. The sky's got to be pretty dark. And then the comet is visible for a total of about, depending on your latitude, it's visible for about an hour to an hour and a half in the evening. So you got a slot in there. It's not like 10 minutes. You got some time to look for it. I encourage you, if you're having any difficulty finding this fuzzy looking object, it looks fuzzy. That's the thing to key in on. Stars look like points through your binoculars. This will look like a glowing ball with a stubby tail. if you have any difficulty, take your cell phone and do an exposure of that part of the sky. And then you should be able to identify the comet as a fuzzy spot and then locate it using something in the landscape. Like, oh, there's a tree here. If I just go off to the right of the tree, put my binoculars there, I'll see it. So your smartphone can be really handy and helpful in locating and identifying the comet.
Yes, and we do have articles at earthsky.org, which we don't have these charts in those articles yet because they're hot off the press. Bob made those for us today, but we will put the charts that are showing Comet Lemmon, Comet Swan, and Comet Atlas into the various articles at earthsky.org so that you will have access to those charts. And we'll also put the links to those articles into the post description here. So so that's the first one, Comet Lemmon. That's the easiest one. Before we leave Comet Lemmon behind, let's look at this image, this photo that you took, Bob. Talk about the tails.
Oh yeah, this was I took this with a very common instrument. A lot of people have these nowadays. It's called a C-Star S50. So it's a smart telescope. You use your cell phone to operate it, point it at a target, takes the picture. What's interesting about the photograph is that we actually see two tails here. The broader one that gives it that lovely parabolic shape, that is the dust tail. So we have vaporizing ice because of sunlight and solar heating. Within that ice is dust, and then the sunlight blows it back, actually pushes it back to form the dust tail. But overlapping the dust tail in this picture, you see the skinny little thing in the middle? That is the gas tail. So you've got gases that are also vaporizing from the comet. They are fluorescing in ultraviolet light that the sun is pouring out in our direction. And that fluorescing makes it glow. And we happen to see them at this date overlapping each other, gas and dust. So it's really cool.
Very cool, super cool. And, this comet right in this image looks kind of like, a little bit like the other comet and the fact that it does have a tail. So this is the other comet that you might be able to see right now. This image was taken on September 15th when Comet Swan was passing next to the bright star Spica, which Bob calls Spica.
And do you say, I call it Spica, and do you say potato or potato?
I say potato. What do you say?
Okay, I guess we agree on that then.
It's those Arabic names that are tough.
I know. But there are indeed two pronunciations of that. But it's a gorgeous picture. This was taken, as Debbie had mentioned earlier, when the comet was closer to the sun. It was brighter, had a more prominent tail. It has changed a little bit since then. And it looks more like this right now. This photograph is by Chris Schur from Arizona, just taken on October 19th. Here you can see the bright head of the comet, right, which glows with that lovely kind of, not Mediterranean, but we'll call it sort of an aqua color. But notice how much fainter the tail is. The comet is farther from the sun. The tail is faint enough that you will not pick it up in your binoculars. But the bright head of the comet should be pretty easy. Again, it'll look like a fuzzy spot in your binoculars with a brighter center. So you see a bright little fuzz ball there.
And Bob, what's it going to take to see that greenish color? Can you see that at all with binoculars, or is it just going to be white?
It's mostly going to be white through most binoculars. A telescope, though, something like a 6-inch telescope or larger, will brighten it up enough so that you'll be able to see that lovely color. And it's very peculiar. It's special to comets, and it's something kind of nasty, Debbie, what causes that blue-green color. And it is it's a type of carbon gas that fluoresces in sunlight. Once again, we have ultraviolet light from the sun kind of making those gases excited and fluoresce. And it's called diatomic carbon is what's making it green.
And a lot of comets do show this greenish color.
They do. And when you get a bright, close comet, it is so beautiful to see either in binoculars or a telescope. It's such a beautiful, almost surreal color to view.
Yes. So let us show a chart of this comet.
let's see where it's going. So you look to the northwest and west right now to see Comet Lemmon. To see Comet Swan, you face almost due south at a similar elevation, kind of lower in the southern sky. And it doesn't have a really bright star like Arcturus to help us out, or the Big Dipper, but there is one star in there. You can see it towards the top, called Altair, and it is the brightest star in the constellation of Aquila, the eagle, and that is all part of the summer triangle. So you can spot Altair, and then to the left of Altair, towards the southeast, you'll see the planet Saturn. So that comet, Comet Swan, is going to be trekking between those two bright stars. So you can kind of triangulate with your binoculars using those two bright objects, plus several other stars that I've labeled here to help you find your way in this part of the sky. You can see it's also moving to the east, and it's moving northward.
Yes, and Comet Swan is not as bright as Comet Lemmon. It's barely within the limit for viewing with the unaided eye. You will probably need some optical aid for this one.
Yes, absolutely. Well, it's Comet Lemmon is magnitude 4, so visible from a dark sky without binoculars. This is at magnitude 6. So it's right, like you say, Debbie, at the naked eye limit, but should be very obvious in binoculars.
Yes. Okay, but we have a third comet. And in many ways, I think this one is the most exciting of these three objects.
It is, because it's not from around here. That's
It
what makes
is
it
not.
special.
It is not. And this is actually the discovery image of this object. So that was these images were taken on July 1st. This is the famous interstellar object, 3I Atlas. It's the world's third known interstellar object to enter our solar system. And it's a comet.
It's a comet. It looks like just a blip there, doesn't it? But again, this was the discovery image. This is back in July. Since then, the comet has gotten closer to the sun and closer to us. And it's right now, you can't see it right now because it's lost in kind of the glare of sunlight. It's kind of up in the daytime sky. But great news, Debbie, this comet is going to be working its way pretty quickly now into the morning sky, and it will appear before the start of dawn, beginning about November 11th, thereabouts, and then going all the way into December. And it will first appear down in the southeastern sky and gradually move upward with time. But it looks like a normal comet. It has a fuzzy coma, we say, around it, a bright center where the nucleus is buried in there. It's estimated to maybe be 1 kilometer across. So it's quite tiny. And the whole thing of fuzz around it is that dust and gases that the comet is giving off as it's heated by the sun. It's interesting. You've got this comet from another solar system, and here you've got our sun basically kind of working it over so that it looks like a normal comet that you would see in our solar system.
Right. And there's no reason why it shouldn't look like a normal comet that you'd see in our solar system, because presumably all solar systems have comets, and it makes sense that some of them would get jarred loose and start moving through interstellar space. In fact, one of the scientists I talked to about this said that a recent study suggested that there may be 50 of these objects moving through our solar system at any given time. But up until recently, we didn't see any of them. And now we don't see very many of them just because at first we didn't have the technology to see them. And now we don't see them all because we just don't notice them.
Yeah,
because
and they're quite
space
faint.
is vast.
Space it's too big, which is but what's interesting in all that bigness, that vastness of space, what to me is most fascinating is that you've got this object that, could potentially be 7 billion years old, come from a different part of the galaxy, and yet when it's here in our solar system, my gosh, it looks familiar. It's that familiarity, no matter where you go in the galaxy, kind of looks like home. So there's that, we share so many things with so many other star systems. I believe, across the entire universe. And that familiarity makes me very happy. Makes sense that we all share the same elements, and the same physical processes happen everywhere in the universe to make this great diversity of things that we all share.
And I love the phrase, our home galaxy, the
Mm.
Milky Way, because it's our home. It's our home in space.
It's a really big home with lots of rooms too. Lots and lots and lots of rooms.
That's right. That's right. And we do have a chart
Hmm.
uh, for this too, which we're going to get to in just one second. But before we get there, we wanted to show this image
There it
because,
is.
yeah, the last time Bob and I talked about this, it was prior to October 3rd. On October 3rd, the Three-Eye Atlas went past the planet Mars. It went pretty close to the planet Mars. And of course, Mars has lots of spacecraft orbiting it or on its surface or something in there. The idea was that maybe we could turn some of those spacecraft on Three-Eye Atlas and get its image. But this is the best image I've seen so far from a spacecraft orbiting
Well,
Mars.
as we know,
It's
it wasn't
not very good, is it?
not so great, but so much counts that we tried. Trying means a lot. And of course, the instrument wasn't made to observe comets, but they tried anyway to see what they could pick up. Interestingly, something else is going to happen with this comet, with another spacecraft. We have a Jupiter-bound mission. It's called the Europa Clipper. It's going to be going to the moon Europa, the ice-covered one, going to be studying it up close. And where it is right now, en route to Jupiter, it's in a place where at the end of this month through about November 6th, the gas tail of this comet is going to wag its way and pass over the spacecraft. So the spacecraft could potentially be used to study this gas tail and what's in it and how fast the particles are moving. However, we got a situation, Debbie, you're familiar with. We have a government shutdown right now. So it's unclear whether NASA has personnel to sort of bring these instruments out of hibernation and make those connections so that we could examine the comet. So let's hope that gets over with really quick.
That's right. But there is yet another spacecraft that's not an American spacecraft. It's the European Space Agency's Jupiter Icy Moons Explorer, or JUICE. The JUICE spacecraft will be observing the comet with various instruments between November 2nd and 25th. And we'll see what we get from that.
Yep.
Oh, but we'll have to wait a while because the JUICE observations, for some reason, aren't expected until February of 2026.
Yeah.
So there you go.
Yeah, it reminds me a little bit of the Pluto spacecraft, New Horizons. We had to wait for some of those for some months as well.
That's right. But Bob, you gave us the good news about this comet, that it's going to be coming back to our morning sky. But now tell us the bad news.
The bad news? Let's see. Do you mean that it's kind of on
You
the
need
face?
it. You need an 8-inch telescope to see
you need a
it.
telescope. That's okay.
You need an not just a telescope, but you need an 8-inch telescope to see
Something
it.
like
So like a
that.
little refractor? No, probably not.
Probably not, but it depends upon how skilled you are as an observer, how dark your sky is. So it's hard to set an exact limit, but you can see the comet here returning to the morning sky after its closest approach to the sun, at which time we expect it to maybe be around 10th magnitude or 11th magnitude, and that would put it potentially you would need an 8-inch telescope, but you might be able to see it with a 6-inch telescope even. By the way, Debbie, that's a brighter forecast than originally, when it was expected to be even fainter, 12th magnitude. But it will first appear in Virgo above one of your favorite stars, Spica, and gradually move upward higher in the sky, so it will become easier to see. It will be fading through this time slowly, but it will climb up through Virgo, up into the constellation Leo, getting ever higher in the sky. So I think many, many amateurs will have the opportunity to see this comet in a telescope. And of course, there'll be some opportunities where it'll be online too. So if you don't own one, don't worry. we'll be letting you know about those opportunities where you can see it virtually on your screen in real time.
And you asked me before we went on the air if I would be willing to get up early and go to a star party to see this. And I think
Yes.
I told you no, but I'm changing my mind. I would be.
Oh,
I would be willing to.
good for you.
It's
That's
it's
great.
a woman's privilege to change her mind. So
Oh,
there you go.
yes. Well, I do hope you get to see it, and I hope the people watching right now also get a chance to see it, or if not this particular comp, to follow it online to see how it develops, and then get a chance to see the two evening comets as well, which are well placed right now, and there's still no moon to brighten the sky. So the next week is really a great opportunity.
And Bob, just quickly, a lot of people are asking, where should I look from this place and that place? Tell us again, how do we see those two comets in the evening sky? Which way do you look?
So for Comet Lemmon, the brighter of the two comets, where you'll see a tail in binoculars, that is visible low in the western sky at the end of evening twilight into early night. So, and you've got, depending on latitude, roughly an hour to an hour and a half of time for viewing it. Comet Swan is visible for a longer interval of time. It will be in the southern sky a little bit higher up. So we look south for that comet. And again, with a pair of binoculars, don't expect a tail, but do expect the famous, what describes most comets, a fuzzy blob. Expect a nice little fuzzy spot. And you're seeing the comet, you're seeing it active in the sunlight, you're seeing the dust coming out of it. So should be a good view. So,
and do try the trick with your phone. Aim your phone, open your phone's camera, aim it at where you think the comet should be, take a picture, and your phone will show it before your eye will. So then you can say, oh, it's just above that tree or whatever.
Yeah, it's to the right of that house, or it's above the peak of a roof of my house, or whatever. When you do take a picture with your phone at night, phones, both Androids and iPhones, will give you automatically a 3-second exposure. But you can adjust that up to as long as you like, up to 10 seconds on an iPhone, for instance. Do remember to tap your screen when you aim the phone at the sky so it focuses on the stars. So you can pull it up. Sometimes it autofocuses just fine, but just to be sure, pull it up, touch the screen, and then you're good to go.
I did that just the other morning when I was taking a picture of the beautiful little crescent moon and Venus.
Yeah.
Gorgeous in the morning.
That was really a beautiful scene. It's just, astronomy is just so full of wonderful little moments like that.
It always has more. It's amazing. Like how long have you been interested, Bob, in astronomy?
Since I was 11 years old. So,
there you go.
Yeah.
A long time.
Yeah, it inspires you throughout your life. So
it does. It never gets old. It's a wonderful thing. Okay, that is our show for today, and I have been here with my friend Bob King, aka Astro Bob. Bob, where can people find you?
You can find me on Sky and Telescope on their website and magazine, but also I'm mostly online on Facebook. It's Astro Bob's Astronomy for Everyone.
Yes, and it's awesome. Bob has so many great things on his Facebook page. So
thanks, Debbie.
You do. It's wonderful. We will be back later this week or early next week to talk about the growing weak spot in Earth's magnetic field. So that'll be exciting, and we hope you'll join us then. One Earth, one sky, Earth sky.